In this example problem, we are going to find the five-number summary for the low temperature, daily low temperature, for a 20-day span during February 2026 in where I went to college, Oneonta, New York. And we have in our data set the low every respective night from February 1st all the way up to February 20th. We're going to find that five-number summary by finding the min, the first quartile, the median, the third quartile, and the max. So the smallest number, the highest number, the middle number, and then the number that's the middle of the left side, if you will, the 25th percentile of the data, and the number that's the middle of the right side, the 75th percentile of the data. Going through, we can start by finding our easy points to find, the min, the max, and with a little work, the median. To do so, it's going to be easier if we put these numbers in numerical order. So again, going through and visually identifying, I can see the lowest temperature of any of these 20 days was the low of 1 that we had on February 1st. The next lowest temperature, I'm looking around up in here and I see we have 2 days, Valentine's Day and the day after, where it was 3, and I could just keep on going doing this and knocking off every single numbers, slashing them off until I accounted for all of these, but using Excel, it's much easier if you use the sort function. So I'm going to sort all of these in ascending order equals sort. The array of data that I want to sort is everything in row 5. When I hit a comma, I don't need the index, so I can skip that part by hitting another comma. My order I want is ascending, which tells me I need to put a 1 in for. And then all of these numbers are in their own separate column. So by column would be true. So I'm going to type in true and I'm going to hit enter. And it's going to sort all of those numbers for me. As you can see, we're now in ascending numerical order, which makes it very easy to identify what's the smallest number. We have a minimum low temp of 1. And what is the largest number? We had a high low temp. I know that sounds weird to say, but the warmest low temperature that we had during this 20-day span was the 27. It was on February 20th. Apparently, they got a heat wave coming in. So 27 is going to be our max. And now we need to find the median. And we can, if we want to, just keep crossing off both ends, working our way in until we find the middle point of the data. But you can also use these cheat formulas to get there, and it depends on if your number is odd or even. In this case, we have data for 20 days, which is an even number, so our number of observed days or number of observations is even, which means we actually have to find two values within the data, two positions, and then find the average of those two values. So let's go and start off over here. I'm going to use this formula right here, n divided by 2. So the position of the first number, we have 20 days in our data, is equal to 20 divided by 2, and that's 10. The position of the second number that we have would be n divided by 2 plus 1. Well, if n divided by 2 we just found was 10, n divided by 2 plus 1 is just going to be 11. The value of the 10th number in our data, we can go and count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That number right there is the 10th number in our ordering, and that value, the temperature for that is 5. It's also going to later ask us for the value of the position of that second number we found. That was the 11th number in the sequence. And if this is the 10th number, that makes this first 7 the 11th number. So value of the number in the first position was 5, and the value at the position of the second number is 7. And down here, we're just asked to find the average of those two numbers right there and presume that to be our median low temperature. So you find the average of any two numbers, add them together, and divide by 2 equals, open a parenthesis, 5 plus 7 divide by 2. And that's going to come out to 6. So our median in this case is 6. And it was found as the center spot between the 10th and 11th number. Well, again, going back up to the top, this was our 10th number, and this was our 11th number. So for a little visual representation right here, let's draw an arrow pointed up at it. right there. Our median is exactly between those two numbers, which means all these numbers over here are going to be the left side of the median, which I'm going to change to being purple, I suppose. And the numbers on this side of that arrow are going to be the right side of the median, which I'm going to change to orange just to more easily identify them. So I have my min, my max, and now my median, which the midpoint between 5 and 7 would be 6. All I've got left to figure this out is to figure out what my first and third quartile are. And the first quartile is just the median of the left side of the data or the median of these purple numbers. How many purple numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I can use that n equals 10 now, the same way that I use it up here to find the median of the left side of the data. So the position of the first number is n divided by 2 right there. So equals 10 divided by 2. And that is going to be 5. And then over here, n divided by 2, which we know to be 5, plus 1, well, 5 plus 1 is 6. So for the left side of the data, I have to find what is the fifth number in the order, what is the sixth number in the order, and eventually I'll find the average of those two and declare that to be my first quartile. So going over 1, 2, 3, 4, 5. The fifth number in this set of purple numbers is 4. I also need the sixth number, and the sixth number will be 5. So the value at these positions are 4 and 5. And then I'm going to declare the first quartile to be the arithmetic mean average of those two. So I find that by adding them together and dividing by 2. And it's 4.5. You do not have to have a whole number. Our first quartile, low temperature, is 4.5. So I'll go back to my arrow drawing ways over here. And I'm going to insert a shape. We'll take another arrow. We'll take a skinnier arrow this time. There we go. And it was right here in the middle. Of course, it drew it upside down. Let's rotate that guy and flip him vertical. Perfect. So if that is the first quartile, it's splitting these purple numbers evenly. There's 1, 2, 3, 4, 5 on the left side of the arrow, and 1, 2, 3, 4, 5 on the right side of the arrow. Now all we got left is the third quartile, and we're going to repeat that same process we just did to find the first quartile for the orange numbers, to find the middle point of the numbers that are above the median. So these formulas are still going to be exactly the same we used before, but because there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers on the right side of our median. So 10 divided by 2 means that that's a fifth number. And 10 divided by 2 being 5, we add 1 to that to find the second position we have to locate. And 5 plus 1 is 6. So what are the fifth and sixth orange numbers that we have listed up on top? Well, 1, 2, 3, 4, 5. The fifth number is 11. And 6, the sixth number is 12. So down here, the value of the first number would be 11. And the value of the second position would be 12. And now I just got to find the average of those 2 points by adding them together and dividing by 2. So equals 11 plus 12 divided by 2. And our third quartile, low temperature, would be 11.5 degrees. And now I have all the information that I need to prepare my 5-number summary for this data. Min, the lowest low temperature, the coldest it got during the whole entire month, we already determined to be 1 degree. For the first quartile, we solved it right here. It was 4.5. The median we solved up above to be 6. The third quartile, we just determined right there, would be 11.5. And the warmest night that we have had thus far in February in Oneonta, our max low temperature is 27 degrees, determined right here. So that is our 5-number summary. So if somebody says it was really warm in Oneonta this winter, this February, we had a night where the low was 27. It was almost above freezing at night in February, which is crazy for upstate New York. Well, while that's true, It's not representative of the data. The third quartile means that there's 75% of the nights it was 11.5 degrees or colder. Yes, that did happen, but it's not something that's typical of the data. On most nights in February and Oneana, you're going to have a low that's barely in the double digits. If you wish, you can use Excel's functions. I'm going to copy and paste this guy down really fast. You can use Excel's functions to solve for you these same points that we had. Let me just make this a little taller so you can see what it says. So let me just delete that out. Our min, our max, and our median can easily be found by using those respective functions. For the min, it's the min function, so equals min. And then we're going to go up and we're going to highlight the array of data we want to find the minimum of, which is all of our stuff in row 5, very much where we started from. And I'm going to go and I'm going to enter on that. And we see our min is 1. I'll go to the max and I will use the max function to find the maximum or highest amount from that very same array of data points. And highlighting all the numbers in row 5 one more time, just like we found by hand. The max was 27. We can even do this for the median. Equals median. So I'm going to find the median of that same array of data in row 5. And the median of B5 to U5, closing the parenthesis, is 6. So we got all the same points that are over there. To find our quartiles, we are going to have to use a quartile function. And this is where I regret to inform you that for the purpose of this class, when you have an even number of data points, we have 20 in here, Excel doesn't work the same way that the methodology taught in this class works. You would use the quartile.exc function or exclusive quartile, if you will. So equals quartile.exc. And the first thing it's going to ask us for is the array. So I'm going to go find and highlight, excuse me, that same array of data. Scrolling back down. The second thing it asks us for is what quartile we want. So I'm going to put a comma in, and that's going to flip over and ask, do I want the first, median, or third quartile? Well, I want the first quartile, so I'm going to hit 1. Close the parenthesis and hit enter. Let me do the third quartile as well. So equals quartile.exc. Highlight all of that same data. In cells B5 to U5, hit comma, and this time I want the third quartile, so I'm going to type in a 3 and enter, and it gives me 11.75. Well, that's curious. As you can see, the min is the same way using the Excel function that we had when we did it by hand. The median is the same number that we found when we did it by hand. The max is the same number that we found when doing it by hand. But the quartiles are just ever so slightly different. Why could that be? Well, here we found the third and first quartile by taking the mean arithmetic average of the two numbers that we know the quartile has to lie between. And while that is a perfectly acceptable method, it's not the only way to do it. And that's the issue here with us using the quartile.exe function is in MA110, this is the methodology that's taught to find the mean average of the two numbers that you know your quartile is actually between. Excel, by default, uses a different methodology that's not taught in this class. And that is going to give you a number that's close to what you're looking for, but not exactly. So for the purpose of your Pearson homework, you probably have to do the quartiles by hand if you have an even number of data observations in your data set. You could use this if you wanted to use the quartile.exe function and find the number that's the closest to it in the list of answers that it gives you, but I'm not guaranteeing that it is correct. So for the purpose of your Pearson homework, you're going to want to find the quartiles the long form way, if you will. All that being said, you are going to have Excel projects in here, and if you want to use Excel's quartile.exe function to find the quartiles for your Excel projects, I am 100% fine with that. It is close enough. If somebody came to you and said, on 75% of days, our low was 11.5 or smaller, and somebody else argued with, no, it wasn't, it was 11.75, does that quarter of a degree really matter for the statement that you're actually trying to make? And that statement is, it is cold in upstate New York, in February.